Hello students, good morning. Welcome to lecture number 2 of unit first, that is solutions. In first lecture, you have learned what a solution is and what are the various methods to express concentration of a solution. You know very well that a homogeneous mixture of two or more components is solution and their relative amount is called concentration. We learned various methods of concentration like mass percentage, volume percentage, mass volume percentage, which is also called strength. Then you learned parts per million, mole fraction, molarity, and molality. Today in this lecture, we shall learn two more methods. One is, you see here, normality, and the other method which we are going to take is formality. So now, first of all, let us learn these two methods of expressing concentrations. Then after that, we shall study solubility of solutes in solvent. Now let us first take the eighth method of expressing concentration of a solution, which is called normality. First of all, let us define what normality is. It is the number of gram equivalents of a solute dissolved per liter of solution. Okay, so what is normality? It is the number of gram equivalents of solute dissolved per liter of solution. Now question arises that what does it mean by number of gram equivalents? So number of gram equivalents is equal to equivalent mass in grams. Okay. Now, what is equivalent mass? Equivalent mass of a solute is its molecular mass, you can say molar mass in grams, divided by its valency. Now, what is valency? Valency is the total positive charge or negative charge. Simply, for simplicity, you can say that valency is the total positive charge or negative, any, in formula of a substance. Like in case of NaCl, Na has 1 plus, Cl has 1 minus, so valency of NaCl is 1. CaCl2, valency will be 2. HCl, valency is 1. H2SO4, valency will be 2. Okay, simple. Now, so number of gram equivalents of a solute dissolved per liter of solution will be called valency. Will be called normality. And how does we make formula of normality? Normality is shown by capital N. N is equal to number of gram equivalents upon volume of solution. Of course, volume will be in milliliter. To convert into liter, we have to multiply this by 1000 because 1 liter consists of 1000 milliliter. One more thing, you must keep in mind that liter is also called decimeter cube, dm cube. Sometimes in statement it is given dm cube. Dm cube means decimeter cube. 1 by 10th of a meter cube is actually 1 liter. Okay. So normality is equal to number of gram equivalents upon volume into 1000. And if we slightly manipulate it by considering molecular mass, it becomes molecular mass upon valency into 1000 upon volume of solution in milliliters. Okay. Now if we see here carefully, molecular mass upon volume of solution into 1000, it becomes molarity. Okay. So we can replace molarity here. That is, normality becomes molecular mass upon valency into 1000 over volume of solution. So this is for 1 mole. We are talking about 1 gram equivalent and 1 mole. 1 gram equivalent is 1 gram equivalent is equivalent weight, and 1 mole is molecular mass. But if we have more or less than 1, then you know that number of moles can be determined by taking number of moles can be determined by taking given mass upon molecular mass. Let us make this formula for any number of moles. We know number of moles is equal to W upon capital M. That is given mass of solute, you can say here, upon molar mass of solute. Okay. So if we use it here, it becomes normality is equal to given mass of solute upon molar mass of solute into 1000 upon valency, here V for valency, into 1 by volume of solution in milliliters. Now in this formula, you know that this thing, given mass upon molecular mass into 1000 upon volume of solution in milliliters, this thing is called molarity. So we can get that normality is equal to molarity divided by valency, or you can say that molarity is equal to normality into valency. Now it should be clear to you that if valency of a substance is 1, valency of a solute is 1, then it has same normality and molarity. Like HCl, a 1 normal solution of HCl is also 1 molar because its valency is 1. But 1 normal solution of sulfuric acid will be 2 molar because its valency is 2, and vice versa. Now you can solve the numerical in previous practice problems which are involving normality, equivalent weights like things. Okay. So this was the eighth method of expressing concentration of solution, that is normality. Now one more term is there which is called formality. Let us discuss about this also. So what is formality? Actually, formality is not widely used because it has nothing more important. It is just a technical term. Formality is used first of all only for ionic solids. You know ionic solids? Solids are of many types: covalent solids, crystalline solids, molecular solids, ionic solids, metallic solids, you know. So, first of all, this term formality is used only for ionic solids. It is used to express concentration of solutions having ionic solute. Okay, now question arises, why we need separate term for ionic solutes? What is the logic behind it? The logic is that ionic solids, solutes, do not exist in the form of molecules. Okay, let me write down. Ionic solids don't exist in the form of molecules. So, their formula mass cannot be called molecular mass, and their number of moles are called formula mass units. Hence, term formality is used at the place of molarity. Listen again. Ionic solids don't have molecules, so their formula mass can be called molecular mass. Normally, formula mass is actually molecular mass, like H2O 18, formula mass also called molecular mass. Glucose C6H12O6 formula is 180, formula mass also called molecular mass because glucose exists in the form of molecules. But in case of NaCl, NaCl is formula. NaCl is not a molecule. When we dissolve NaCl in water, NaCl ionize. Na plus and Cl negative exist independently in solution. NaCl is not a molecule, so mass of NaCl 58.5 is not its molecular mass. जब molecules नहीं है तो molecular mass का है का? Then what is it? It is formula mass. Okay. Mostly in classroom, even we teachers call it molecular mass of NaCl, but that is wrong. It should be called formula mass of NaCl. All ionic compounds have formula mass. Covalent compounds exist in molecules, so their formula mass can be called molecular mass. Mathematically, both formality and molarity are same terms. Technically, they are different. In case of ionic crystalline solids, term molarity is replaced by formality, and number of moles are called formula mass units. Okay, now let us define it. If you get 1 mark question to define formality, how will you define it? What is the definition of formality? You can define it as like this. So, what is formality? Formality is the number of formula mass units of a solute dissolved per liter of solution. Okay, that is F is equal to number of formula mass units upon volume of solution in milliliters into 1000. If we see deeply, number of formula units is number of moles in case of covalent solutes. So mathematically no difference is there. You can calculate by using formula of molarity, answer will be same, but technically it is different. I think you got it. So these are the two terms which are also used to express concentrations of solutions. But these terms now are not of any importance. These are not used mostly uh, in NCRT book. Even these terms are not there because these are unnecessarily there. But in competitive exams, we get it. That's why I have explained these to you. Now we are going to study about the solubility. What is solubility? Our first topic is over. We have learned various methods of expressing concentration of solutions. Next topic is solubility. Solubility, how to define it? You can say how much of solute is actually dissolved in how much of solvent. Okay, so maximum amount of a solute that can be dissolved in a solvent, that is called its solubility as defined here. Solubility of a substance is its maximum amount that can be dissolved in a specified amount of solvent. Okay, like if I say that 5 gram of this A solute can be dissolved in 100 gram of B solvent, then solubility will be 5 in 100. We cannot dissolve more than 5 gram of that solute in 100 gram of that solvent. Let us take an example. We can take water in a beaker. Like I take 100 ml water. I have a solute like sodium chloride, common salt. I put 1 gram NaCl, 100 ml water. Stir it slightly, it dissolves. I put 1 gram more. Stir it, it dissolves. I keep on doing this. What happens? For example, after dissolving 5 gram, I am stirring it, but it is not dissolving completely. That means the solubility of NaCl in 100 ml water is less than 5 gram. 5 gram is not going into it. Okay. So I will have to find out how much, for example, 4.5 gram is solubility. Okay. Now, if I heat that solution, that will dissolve. Even 1 mole gram will also go into it. That means solubility is affected by temperature. Okay. There are many factors which affect solubility. See here, solubility depends upon nature of solute, then nature of solvent, temperature, and pressure. There are four factors which are going to affect solubility of solute in solvent. But you know, there are different states of solute and solvent, and depending upon their physical states, there are 9 types of solutions. So all these factors are going to affect their solubility differently. Okay. So of course these factors affect, but their effect is variable. We shall discuss it in detail. So first of all, we shall take solubility of a solid in a liquid. And after that, we shall take solubility of liquid in liquid, and finally solubility of gas in liquid. In all these three situations, solvent is liquid, but solute in first case will be solid, then liquid, then gas. And this detail we shall cover in our next lecture. Till then, you can finish all the numericals based upon various methods of concentrations. All those 30 practice problems which I gave you in the form of PDF, you can solve those, and let me know down about your problems so that we can discuss these separately. Thank you up to now for this lecture. Now we shall meet in third lecture, in which we will discuss about the solubility. Goodbye. Thank you.